This is a hypothesis test on one population standard deviation using the traditional approach. In this example, a bottling company claims that the standard deviation of the amount of sports drink in a 12-ounce bottle is no more than 0.632 ounces. A random sample of 31 bottles has a standard deviation of 0.86. At an alpha equals 0.01 level of significance, is there enough evidence to reject the company's claim, assuming that the population is normally distributed? In step number 1 of hypothesis testing, we have to identify the given values in symbolic form. Our sample is of size 31, so n is 31. And it says that our population standard deviation is going to be no more than 0.632. So that's our claim. Sigma is less than or equal to 0.632. But our standard deviation of our sample is 0.866. So S is 0.866 and our level of significance is alpha, or 0.01. In step number 2, we have to identify the claim in symbolic form, which it says that the standard deviation is sigma of the population is no more than or less than or equal to 0.632. That is our claim. Since our claim contains equality, we actually put it in the null hypothesis, because the null hypothesis must always contain equality. The alternative hypothesis is just the opposite of the null hypothesis. So sigma is greater than 0.632, and the alternative should always be the opposite of the null hypothesis. In step number 3, we have to calculate the test statistic, which is a chi-squared distribution, since we're making inferences on a standard deviation. So the formula is n minus 1 times s squared over sigma squared. N is 31, we're going to subtract 1. The standard deviation, or s, is 0.866. We're going to need to square that. And then we're going to divide by the sigma value squared, which is 0.632. We're going to square it. We always obtain it from the null hypothesis because we assume it's true and it contains equality. Calculating that all out, we'll get a sigma squared, or a test statistic of 56.328. In step number 4, we have to identify if this is a one- or a two-sided test. It is a one-sided test to the right because of the alternative hypothesis. The direction of the inequality points to the right, so we'll shade in a chi-squared test distribution on the one tail to the right. We'll put all of our level of significance, or alpha equals 0.01. We'll find the degrees of freedom as n minus 1, or 30. And then we'll look up our chi-squared critical value of 50.892. Our rejection region is then a chi-squared greater than 50.892 because it should match what our picture says. In this case, we have to, in step number 5, we have to determine, does our test statistic lie in that rejection region? And our test statistic is 56.328. Our test statistic does lie somewhere in this rejection region here, so we're going to reject our null hypothesis because our test statistic lies in that rejection region. In step number 6, we're going to restate that we've rejected the null hypothesis. And then we've got to determine if we're rejecting our null hypothesis, since our claim lies in that, we're going to also, in essence, reject our claim. But we have to restate what the original claim was, and we say that there is not sufficient evidence at the alpha equals 0.01 level to suggest that the standard deviation of the amount of sports drink in a 12-ounce bottle is no more than 0.632 ounces. So that is our inference on standard deviation, doing hypothesis tests on one population.